Thank you for watching this Hexagon Geospatial e-training module, Corridor Analysis with GeoMedia. In this module, we'll use a sample proposal for a road right-of-way widening study to analyze the proposed changes and see the impact to parcels along the road. You'll start with a basic planimetric map that portrays road centerlines, parcels, and buildings. In this workflow, you'll identify streets by using the attribute query command, create the right-of-way by running the buffer zone command, locate buildings that touch the right-of-way by using the spatial query command, determine how much of each parcel is contained within the hypothetical right-of-way by using the spatial intersection command. You'll count the number of impacted buildings and determine the potential cost of property acquisition for the proposed right-of-way by using the aggregation command. And finally, summarize the results by using the analytical merge command to calculate the total estimated cost for each parcel class, residential, commercial, government, and so forth. First, you'll perform an attribute query to identify the specific road to evaluate for the right-of-way analysis. With the Corridor Analysis GeoWorkspace open in GeoMedia, select the Attribute Query command. In the Attribute Query dialog, in the Select Features In field, click the arrow, scroll down, and select Street Centerline. Click the Filter button. On the Filter dialog for this feature, select the full name attribute and click the arrow. Select the Equal button as the operator. Click the Show Values button and click Yes. With the list displayed, begin typing in the name of the street you want, North Hickory Boulevard. As you begin to type, the list is filtered to display the available options. Select North Hickory Boulevard from the list and click the arrow, and then click OK. For the query name, you can first copy the default value to the description field. Define the output query name as Q1 Find a Street. For the style, select a predefined style name that matches the name of the query and click OK. Uncheck the option to display Query in Data window and click OK. The query is added to the map window. You'll create the right-of-way by running the buffer zone command. Select the buffer zone command. On the buffer zone dialog, specify the previously defined attribute query Q1 Find a Street to place the buffer zone around. For the distance, select Constant and type 25. For the linear end cap, select Rounded, and for Merge option, check Merge Touching Buffer Zones. Copy the default query name to the description field. Type Q2 Buffer Q1 for Zone for the output query name. For the style, select a predefined style name that matches the name of the query and click OK. Click OK again and the query is added to the map window. The map window depicts the proposed study area and illustrates the spatial relationship between buildings, parcels, and the hypothetical right-of-way. Next, you'll perform a spatial query to locate buildings that touch the right-of-way. Select the Spatial Query command. For the first feature, in the Select Features In field, click the arrow and expand the Des Moines planimetric connection. Scroll down the list of features and select PLM Buildings Footprint. In the Spatial Operator dialog, under That, select Touch. For the second feature, select the previously defined query Q2 Buffer Q1 for Zone. Provide a description. Define the output query name as Q3 Buildings Touching Zone. For the style, select a predefined style name that matches the name of the query and click OK. Click OK again and the query is added to the map. The map window display identifies the impacted buildings in the study area. Now you'll examine the impact on the parcels. Use the spatial intersection command to determine how much of each parcel is contained within the hypothetical right-of-way. Select the spatial intersection command. On the spatial intersection dialog, you'll need to select two features to evaluate and a spatial operator. For the first feature, in the Features In field, click the arrow and expand the Des Moines planimetric connection. Scroll down the list of features and select Parcel Property. The parcels in this dataset include parcels that represent existing street right-of-ways, which are not of interest in your workflow and can be filtered out of your evaluation. To do this, click the Filter button. On the Filter dialog for the feature, select Street Row for the attribute and click the arrow. Select the Equal button as the operator. Click the Show Values button and click Yes. Select N from the list, click the arrow, and click OK. For the second feature, in the Features In field, select the previously defined query Q2 buffer Q1 for zone. Provide a description. Define the output query name as Q4 parcels, isect row. For the style, select a predefined style name that matches the name of the query and click OK. Click OK again, and the query is added to the map. Now that the impacted buildings and parcels have been identified, you will continue your analysis by using the aggregation command to count the number of impacted buildings and determine the potential cost of property acquisition for the proposed right-of-way. The aggregation command uses two feature classes or queries, a detail feature and a summary feature. Detail features are grouped either spatially and/or by attributes to a summary feature. The output is the summary feature with any additional summed information from the related detail features. Select the aggregation command. On the aggregation dialog, select the previously defined queries Q4 parcels isect row for the summary feature and the Q3 buildings touching zone for the detail feature. On the Spatial Aggregation tab, select Overlap for the spatial operator. On the Output tab, select Largest Overlap for the resolution operator. In the Output Functional Attributes field, right-click and select New, Count, parenthesis, asterisk, parenthesis. This will create an attribute that counts the number of buildings. To rename this attribute, click the Properties button and rename the output attribute as FA_num_buildings. Click OK. Next, you'll build an expression that sums the square footage of the detail intersecting geometries. Click the New button. On the Functional Attribute dialog, define the attribute name FA_isect_SQFT and define the expression that calculates the square footage of the intersecting geometry. Under Functions, click Area. Area parentheses displays in the expression field. Under Attributes, click Input.IntersectionGeometry. Area parenthesis Input.IntersectionGeometry is in the expression field. Type, comma, projected mes, comma. Select Constants under Categories and select Square Foot under Constants. Click Add. Next, you'll build an expression that calculates the percentage of the parcel that overlaps the right-of-way buffer zone. On the Functional Attribute dialog, define the attribute name FA_row_PCT and define the expression that calculates the percentage of overlap. With the cursor in the expression field, under Attributes, select Output.FA isect square feet. Click the Divide button. Select Input.ShapeArea. After verifying the expression in the expression field, click Add. With the previous functional attributes defined, now you can build an expression to estimate the cost of each parcel based on the number of impacted buildings or the percentage of parcel overlap detected. On the functional attribute dialog, define the attribute name FA_EST_price and define the expression that calculates the percentage of overlap. Select Logical from the category. Select If for the function. The expression appears in the expression field. For the attributes, select output.fa_num_buildings. Click greater than or equal to and type 1. Click OR. From the attributes, select output.fa_row_PCT. Click greater than or equal to and type 50, comma. Under attributes, select input.totalValue. Type comma. Select output.fa_row_PCT. Type a space and click multiply. Select input.landValue. Specify a format of currency and a precision of 2. Click Add, then click Close. Now that all of the output functional attributes have been defined for the aggregation, provide a description and define the output query name as Q5ag4est_cost. For the style, select the predefined style name that matches the name of the query and click OK. Click OK again and the query is added to the map window. With the feature aggregation complete, you can continue summarizing the results by using the analytical merge command to calculate the total estimated cost for each parcel class: residential, commercial, government, and so forth. The analytical merge command takes a single table or query as input, organizes the records into groupings based on user-defined attribute selections, and provides a summation of the expressions. Select the analytical merge command. On the Analytical Merge dialog, select the previously defined query Q5ag4est_cost as the input merge feature. For the merge criteria, select the By Attribute option and select the Class DESC attribute. On the Output Functional Attributes field, right-click and select New, Sum, Multiple Attributes. On the Multiple Attributes for Sum dialog, check the FA est price, FA isect square foot, and FA num buildings attributes, and click OK. This will create summed attributes for each attribute selected and provide default names for each of the output functional attributes. Once the output functional attributes have been defined, you will have the option to modify their format and precision. Under Output Functional Attributes, select Sum of FA est price and click Properties. Specify a format of currency and a precision of 2, and click OK. Next, you'll build an expression to perform a conditional count. In this case, you'll evaluate how many parcel right-of-way acquisitions will cost more than $100,000. This can be accomplished by clicking the New button and by creating a functional attribute. Click New. Name the new functional attribute FA_num_over100K. Under Categories, click Statistical. Under Functions, click Sum. Under Categories, click Logical. Under Functions, click If. Under Attributes, select Input.FA_est_price. Click Greater Than and type 100,000, 1, 0. Click Add and then click Close. Now that all of the functional attributes have been defined for the analytical merge, provide a description. Define the output query name as Q6 cost by class. Ensure that the option to display merge in map window is unchecked. Ensure the option to display merge in data window is checked and click OK. The resulting query is displayed in the data window. Select the Sum of FA est priced column. Click the Table tab and click Column Statistics. The statistics for your analysis are displayed. By using the commands shown, you are now able to use a proposed right-of-way widening study to determine the impact on surrounding buildings and parcels by calculating the number of affected buildings and the potential cost of property acquisitions. Thank you for watching this e-training module from Hexagon Geospatial. For more e-training, please visit hexagongeospatial.com/e-training.